Hello and welcome back to the engineering drawing course. This is section 8, that is geometrical constructions. In this section we are going to see some special curves and conics. First, geometrical constructions consist of basic concepts of engineering drawing like dividing a line and drawing curves, special curves, involutes, for example cycloids, parabola, hyperbola, etc. Geometrical constructions consist of foundational concepts of engineering drawing, and many of those concepts we have already covered in section 2 of this course, like drawing of pentagon, hexagon, drawing of circle, the difference between radius and diameter. All those basics we have already covered in section 2. These are actually classified under geometrical constructions of engineering drawing. Here we are going to complete the curves used in engineering practice. And that will be conics and some special curves. Conics will have hyperbola, parabola, ellipse, etc. And special curves is going to be cycloid, epicycloid, hypo-cycloid, and some involutes. So let us see them one by one. So first, we will discuss about conics. First, what is actually a conic? Conic is a curve formed along the section plane obtained by cutting the cone. Depending upon the section's plane angle, conic can be a circle or an ellipse or parabola or hyperbola. So as we have already seen in section 6 of this course, section of solids, uh, you you know about section plane very well. And section plane can be parallel to HP, perpendicular to HP, or else inclined to HP, and the same cases with respect to VP also. So here, depending upon that angle, when we cut a cone, yes, when we cut a cone, we will get some shapes. For example, if we cut that cone parallel to the horizontal plane, we will get circle from the top view, and that circle is a part of conic. So conics are circle, ellipse, parabola, and hyperbola. So we'll see. So this is our cone. As you know, it will have a base and an apex point. Let us say it has been cut by a section plane, and that section plane was at different angles. So the first case here, section plane parallel to HP, as we have seen already. As you can observe a shape here, and this is called circle from our earlier classes. But here circle is actually a conic, and when you cut the cone with an inclined plane such that the angle is in this fashion, that is it is not equal to 90 degree. You can see here the curve obtained is called ellipse, and you can observe here this is the ellipse. And when you cut the cone in this fashion, which is again here inclined, you will get an shape called parabola, and this is going to be our hyperbola. So circle, ellipse, parabola, and hyperbola. So we are going to solve questions on ellipse, parabola, and hyperbola. There will be different methods by which we can draw this ellipse, parabola, and hyperbola, and we are going to cover the important which will appear in our examination. So now, apart from conics, in this section we are also going to cover special curves, and to name them, cycloid, epicycloid, hypocycloid, and involutes. So let us see them one by one. Cycloid. Cycloid is a curve traced by a point on the circumference of a rolling circle on a straight line. You need to observe these 2 points, rolling circle and straight line. Cycloid is just a curve which has been obtained by tracing the points of a rolling circle on a straight line. Imagine a circle which is rolling on a straight line. So I will show you now. Observe here carefully. So here is a straight line and on which this circle will roll. Observe the letter P there, alphabet which is written. That point we have to catch. Just observe that wherever that point is passing by, I'm leaving some mark just to follow its path. This is the concept. You need to imagine this. Do not worry. There you go. When we join all these paths, we will get one curve, and this is going to be called our cycloid. Epi-Cycloid. Epi-Cycloid is a curve traced by a point on the circumference of a rolling circle outside a generating circle. In contrast to cycloid, epicycloid is a curve traced by a point on a generating circle. Cycloid was a curve which we obtained by a rolling circle on a straight line. But here the rolling circle is on a generating circle. That means a bigger circle will be there. So imagine a big circle on which another circle is rolling. Just observe here now. So here you have two circles. One is the rolling circle and other is the generating circle on which this circle will roll, this smaller circle. And observe the letter P which is written. And now from wherever that P is passing, that means the point is passing, I'm just marking some lines so that afterwards we can join them. So when we join all those points, we will get the path traced by that point on that rolling circle. And that curve is going to be called epicycloid. So this is the epicycloid here which we obtained. Earlier for cycloid there was a straight line, but here we are having a generating circle on which the circle was rolling. This is going to be our epicycloid. Hypo-Cycloid. Again, hypo-cycloid is a curve traced by a point on the circumference of a rolling circle inside a generating circle. So here the difference between epicycloid and hypo-cycloid is that hypo-cycloid is a curve traced by a point on the circumference of a rolling circle inside a generating circle. That means the rolling circle is inside a bigger circle, that is generating circle. So observe here now. This is also very similar to epicycloid, but only thing is the circle will roll inside and we have to trace the path of the point P. You can observe the point P there, and now you can observe that smaller rollers, that rolling circle is rolling inside the generating circle. That is the difference, and the path traced by that point is going to be our hypocycloid. Now some involute of a circle. First thing, involute means a curve traced by a point when we unfold a thread, unwound a thread or a string from any segment. So involute of a circle is a curve traced by the path of a thread or string while it is being unwounded from the circumference. Imagine a circle and imagine one thread which has been rolled over that circle and now unwound that circle. So that path traced by that thread is going to be our involute of a circle. We will see now. Involute of a square. So again, involute of a square is a curve traced by the path of a thread or string while it is being unwounded from the periphery of a square. For example, a square is given on which a thread is wounded. When you unwound the thread and follow the path of the thread, you will find a curve named involute of a square. Involute of a triangle is a curve traced by following the path of a thread or string while it is being unwounded from the periphery. Involute of a pentagon. Involute of a pentagon is a curve traced by following the path of a thread or string while it is being unwounded from the periphery. So from next lecture onwards, we will start solving some exercises on conics and special curves.